Welcome back. Today's Thursday and well, a little bit of snow and white stuff on the ground, I guess. Anyways, today's presentation is I'm going to talk about construction materials. As you likely know, there's a lot of different construction materials out there, but one of the most common ones certainly is wood and wood frame construction. So when I look at wood frame construction, it's been around for many, many, many long-term, we'll say, decades. And it's often the most common option chosen for building a house, and in some cases even we'll call it smaller buildings. So wood is a structural material mainly used for certainly the structure of walls, floors, and the roofs. It's used in what we call today platform framing. In the past, there was another type of framing, the old style, which was called balloon framing. The only major difference between well, there was a few other differences, but the major difference was in balloon framing, the exterior walls went up 2-story, and basically that meant we probably had to have much longer 2x4s or 2x6 wall construction. So wood framing, when we take a look at it and its various related wood-based products is really what I'm going to talk about today. Often we take it for granted. And actually, there's some important details we need to think about when we talk about, and certainly, wood frame construction. We're going to also cover a little bit about when you come to purchasing or procuring wood for a construction project. We want to talk about maybe a few tips and things you need to think about before you build that next house. As I mentioned, we have many types and different sizes of wood out there that is used for construction. It's certainly built from a very good renewable resource. It's flexible and easy to build with. It's easily tailored to a wide range of climatic differences between southern Canada, even far up into the northwest regions of the country. It's certainly strong, durable, and certainly has proven to be very adaptable. Towards the end, I'm going to actually just sort of summarize with some tips and some things of what you should actually look for. So a little bit of general information. There's many types of building materials, and certainly their qualities are used in house construction. And what I'm really trying to focus on is thinking about that word quality, and certainly with any building material. So the question is, what types of adverse conditions result in premature degradation or degrading or premature failure? So in my inspection experience, I've come across, wood rot, certainly damage to wood-based materials, and certainly that doesn't include just wood-based materials, but other materials that are often attached to them, such as drywall, or perhaps even the sheathing, the exterior sheathing that it's being applied to the wood framing. So it requires a reasonable care in its design, its use, its construction, and certainly when we even boil it down to even the detail. So really, typically our construction should be based on the National Building Code, or in some cases, you may be perhaps using the Provincial Building Code. So in Ontario, when I built my house, I had to follow the Ontario Building Code. And I always like to remind people that when we talk about the Provincial Building Code, I just call it the provincial flavor of the National Building Code. So there's really no universal product labeling system, and that's one of the things we have to be aware of when we take a look at wood framing in general. So what are a few of the important details that we really should be looking at that can help in ensuring better quality and longer performance ratings when we come to construction, whether it be a house or, like I say, perhaps another smaller or perhaps even larger building. And we're also going to take a look at what about protection and care of the materials on the building site. Are you aware that of these things when you consider housing and we talk about materials? Well, experience has shown that some materials can adversely affect adjacent materials as well as result in premature deterioration. I mentioned earlier what happens when moisture basically travels through from the interior of the house through the exterior walls and creates damage to the wood framing. So again, there's going to be also other damage to the adjacent materials. As I mentioned earlier, whether it's the sheathing or maybe on the inside, perhaps even the gypsum board or what most people would call perhaps the drywall. So lumber used for construction in Canada is grade stamped. And I think that's a key thing I want to focus on in this sort of discussion is, are you aware that there's grade stamps that you should be looking for on lumber? To show, I don't know why that's there double, but it shouldn't be, that it conforms to the NLGA, the National Lumber Grades Authority, grading rules for Canadian lumber. The National Building Code lists minimum grades for various uses of lumber and wood frame construction. We'll take a peek at a few of those National Building Code, we'll say it requirements. Another thing we need to think about is just not simply the 2x4 or 2x6 or what we would call some people like to call it the stick or the lumber itself. How about engineered wood products? They're routinely used in wood frame construction. These products are equivalent in strength compared to dimensional lumber, but using less lumber, such as it's basically using wood fibers in various different forms and shapes. So this is an illustration from our technical guide for northern housing, and it talks about wood structures in general. And when we take a look at this particular illustration, it's just to portray, we need to think about the residential building being divided into some main categories. It says 4 main categories, but actually I think it's probably more like 5. So we have the floor beams, so at the lower portion down here, the darker orange, the floor framing, okay, sort of that tan or brownish color, the wall framing, certainly the wall studs and the sheathing, and the roof framing. But technically speaking, as I mentioned, I actually think there's a 5th one. We can't really forget about the foundations because quite often there can be wood framing involved with even the foundations, whether it's pressure treated wood, or we need to think about how are the foundations going to be created, and again, in some cases, by some type of wood framing. So the source here is from the technical guide for northern housing. So if you haven't had an opportunity, it's something you should look at, which is very informative information. Next, I'm going to talk a little bit about the Canadian Wood Council. So it was founded in 1959. Is Canada's unifying voice for the wood product industry. It's the National Federation of Associations that basically deal with wood. Their members represent hundreds of manufacturers across the country. The Wood Council participates extensively in the development and the process of building codes, and certainly even to some of the changes that do happen within the building code. So for example, if we take a look at things as design of wood frame structures for 3 stories or less, maximum spans for lumber for beams, floor, roof joists, roof rafters, and so on. And again, that's all dictated, those requirements within building code. There's lumber and stud tables. So again, we can basically look at either spans or how far, how high can lumber studs go? Is it okay to use a 2x4 on a 2-story high building? What happens if it goes to maybe 3 stories? And there's also nailing schedule. So also within the building code, it talks about what size nails are the minimum requirement as far as nailing is concerned. And it's not just the size, it's also the number of. Do we need 2, 3, or more? Or is other types of fasteners acceptable? And of course, we need to also not forget about, in some cases, permanent wood foundations. So I just wanted to kind of back up a little bit and talk about what do we see in a typical, we'll call it lumber yard, and I like to call it, it's called the classification of what is known as yard lumber. So what is a board? And when we think of the different terms such as boards, dimension lumber, timbers, factory or stock lumber, these all have, we'll say some technical reference guidelines. So we can see here boards are typically an inch to inch and a half thick. They're graded for appearance, often used as siding or an interior trim when we think of a board. How about dimension lumber? Well, dimension lumber are things such as the 2x4. Is it really 2 inches? The answer is no. It's actually, that's the, what we'll call it the nominal dimension. The actual dimension of a 2x4, something in the range of an inch and a half by 3.5. So an actual size by the time it's finished and dressed down. In some cases, they're going to be wider. They're going to also be graded for strength or stress rather than just simply appearance. And commonly we see different classifications, which we will take a look at shortly. So light framing, joists and planks, okay. Joists and planks go into the 6-inch and wider range. Decking, 4-inch and wider range. And sometimes we get into with decking select and what they call commercial grade. Timbers are often, basically we think of something that's quite a bit larger. So 5x5 and larger. And again, graded for strength and durability, often stocked in green undressed condition and may be classified as structural lumber. In factory and stock lumber, primarily for manufacturing such as doors, windows, and millwork. So again, the National Building Code and all the provincial building codes call for lumber to be grade stamped or certified. You'll see I keep kind of repeating myself about this grade stamp issue. So I think these are one of the things, if you're not familiar with, you should actually be looking for when we talk about those, we'll call it structural framing, certainly for any type of building. Well, what's this proper grading all about? So the lumber grading. So the grading is essential because it helps ensure the wood is suitable for its intended use. If a piece of lumber is incorrectly graded, it may not be strong enough for its intended application, which could lead to structural failure and potentially dangerous consequences. So in this little chart, so the chart is actually a portion or we'll call it a illustrated snap capture of table 923.42. 923 is basically your wood frame construction in the building code. And if we take a look at it, you'll see the most common grades of lumber include, and I've listed them off to the side, select structural. Okay, and then I pointed to it in the actual table. Number 1 common, number 2 common, and number 3 common. Not so much do they use the word common, but quite often when we refer to it, it's just number 1, number 2, or number 3 grade. We can see if we take a look at this particular caption of the table, it calls the commercial designation. So we can have different types of, we'll call it species of wood lumber. This one I've chosen is what we call, or I call SPF, spruce, pine, and fir. You could have certainly other materials, okay? It could be fir, it could be other types of materials, as I mentioned. So we can see when we take a look at the grading column, we have the grades, or down the bottom, we have construction or standard grade. So for example, we talk about a 38 by 89. Again, the codes use those millimeters, metric. So we're talking about the 2x4. And what happens if we're going to use it with strapping or with bridging? Or so again, just to kind of get you a little bit familiar with the actual span tables, okay, for, in this case, the lumber that's going to be used. So again, we would have to go in and make sure that we've selected the proper size based on the spacing, joist spacing, and how it's applied. Is it going to be with strapping, bridging, or strapping and bridging? So again, the grading is identified within the building code. Well, when we take a look at lumber and wood products, this is again a capture from the National Building Code. It talks about grade marking. So if we take a look at one of the requirements, it says lumber for joists, rafters, trusses, and beams, and for the uses listed in table 9321, basically all our structural framing lumber, or even framing lumber, not alone just structural, shall be identified by a grade stamp. So that's where I like to kind of halt for a moment and talk about look for a grade stamp when you're looking at lumber. If you're getting an order that does not have a grade stamp, there should be a question mark. Is this acceptable? If it's off reserve, for the most part, the inspector can refuse that particular framing material. Okay, so again, we'll take a look at some of those grade stamps shortly. But again, minimum lumber grades for specific end use. So again, when we look at the National Building Code, in the clause requirement up top, we take a look at the use category. So for example, stud wall framing, the very first one, and I'll jump all the way down to say roof sheathing or subflooring. Okay, wall sheathing when required as a nailing base. And it talks about what types of boards and what types of framing and what type of species and categories. So you can see here stud standard number 2 grade for stud wall framing is acceptable. So again, the use of the tables, when we get to know and understand a little bit about the building code, are we building to a good minimum building standard? So it becomes important because I could talk about a lot of other different materials, but obviously lumber and wood products are one of the most common ones encountered when we think about general construction, whether it be a house or, like I say, even a larger building. Well, let's take a look at what grading is all about. I've shown a few examples here. So off to the pictures off to the side, we can see here, this is off of a sheet of plywood. It's kind of got that greenish tinge, so it's been treated lumber. We can see some few dark spots. Those are the knots within the plywood skin itself. And over off to the picture below it, we see these are 2x4s, and we can see the word, you know, kind of on an angle there. And these are select grade 2x4s. And we see the actual stamp above, and that's the mill. So that's where that information comes from, is where was it actually milled and where does it come from? So there's material here, and we also see it's select grade. Select grade, by the way, is a pretty high standard. So when we take a look, when we come back over to the actual grading and this depiction here, we can see here's an example of a grade mark in the lower left. Now it says it's a stud grade, so it's for a stud. It's HRA, heat resistant adhesive was used to it. Okay, so it becomes stronger. Or if we take a look at another example over here, we see HRA again, and we can see a little more information. This one says S dry, so it's drier. Okay, so again, these stamps are things we should look for when we're looking at maybe not just the lumber yard, but what's showing up on site for the build, the actual build. So again, this is understanding a grade mark, talks about the seasoning, the species of lumber. I mentioned SPF before, spruce pine fir, a registered trademark of the accrediting agency. So again, a verification and testing required. The grade of lumber, so this is grade number 1. Okay, and what is it based on? The grading rule in this case is the National Lumber Grading Association. So again, things we can look for that if you go and say visit one of the local lumber yards, these are things you should see. If there's no grading stamps on these, it should be a question mark. What exactly am I getting? Let's take a look at another building product. In this case, we have floor joists. These floor joists, again, an engineered wood building product, again, have to be or should be at least identified by some type of grading mark. In this case, it's CCMC. Well, actually, in this particular case, these floor joists have been tested through the National Research Council of Canada. That's great because it tells us automatically, if I'm the inspector on the job, it meets the building code. There's no question about it. In fact, over to the side here is we'll call it a reduced down copy of the 5 or 6 pages of the actual testing of the actual product itself, material itself. And you'll see, for example, it says here, this was TGI, okay, CCMC 13132-R. What do we see up here? These are approved. They've been tested by the National Research Council. These are automatically accepted within the building code. So again, we get back to this look for the label sort of thing, in this case, grade or grade marks, to indicate that this is approved material. It meets a standard that in some cases goes even beyond the minimum base standard. Well, let's take a look at a few other views here. So we see plywood grading. How is a plywood graded? So we can see there's a grade A, a grade B, and a grade C. And a lot of this, if we take a look at it from a visual perspective, is, well, grade A, I don't see a lot of knots. Very few, if any. Grade B, some dimples here and there. And grade C, we can see more of them. So when we take a look at this, so this was from the source of the Canadian Wood Council again, taking a look at their information. Okay, modified construction varies from standard plywood in that the grain direction of the plies, the number of plies, and the thickness of the panel is modified. So when we take a look at plywood, it's plies in alternating, we'll say, sheets, basically creating our 4x8 sheet of plywood. Standard plywood symmetrical about the center ply is used for the most structural sheathing. Modified plywood is used for the most formwork. So again, because it's going to be below grade, this is probably grade C's better. But if you wanted something a little more, we'll call it finished looking, then we would take a look at this particular grade A. And just turn that off there. National Building Code 2020 version. Okay, this is the most current version. And I mentioned about section 923, and we can see here in section 923, we have, 30-some pages virtually of wood frame construction requirements. Everything from the application to the fastener connections to spans, what happens if we want to cut, notch, or drill, how do we anchor, and going on to beams, joists, wall studs, and so on, subflooring. So again, there's a lot within the building code that we need to be aware of also when we think about wood frame construction. This next one here, again, another table within the National Building Code, lumber studs and planks. So again, we can see here forming part of a particular sentence within the building code. So again, we can see here that information is again provided in the building code. Subflooring, number 3 common, okay? If we take a look at species designations, we can see again some of the species that are found within the building code. So Douglas fir, larch, hemlock fir, SPF, spruce pine fir, and some of the northern species. So again, they're graded according to certainly species and of course, we'll call it the characteristics of the material itself. So when we take a look at code requirements, this is where we can call on the inspector to either say, what I see is good, or perhaps maybe it's not so good, and we need to rethink what's going on here. So if we're saying enforcing code as an inspector, we could say, well, section 9322 on lumber grade says, except for joists, rafters, trusses, and beams, visually graded lumber shall conform to the grades in that particular table. What happens if what you have don't? Well, I guess that's up to the local authority having jurisdiction. And then it goes on machine stress rated lumber, OSB, wafer board, plywood markings, moisture content. Again, another key factor is when we talk about moisture content, I have a moisture meter. I have both what they call one that has a metal probe, and I can measure the amount of moisture in the wood. But if we take a look at it, the moisture content of lumber shall be not more than 19%. Well, if it's left out in the rain and the snow and the elements, it's certainly not going to be 19%. In fact, sometimes you're even lucky if it's 19% coming out of the lumber yard, because did they leave it out in the rain and the snow and the elements? Again, I just wanted to talk maybe a little bit briefly here about termites. I know if we may not hear too much about termites in all areas, but there is a requirement within the code for protection regarding termite and certainly on the other topic there, decay protection. So when we take a look at the map over here, pretty much of most of Canada, we see these dark gray areas, areas in which specific locations with termites have been identified. So for example, more areas within the certainly southern end of the provinces. And if we take a look, for example, I'm way down here at the bottom tip of Ontario. In doing inspections, it was quite often that I would find termites, especially in old wood cottages. You know, so again, the termites came in from the south, and actually they didn't even come in from the south of the USA. They basically were brought over by other elements called ships across the ocean and somehow infected wood in areas such as the deep south of the USA and basically migrated north. So even for my area, areas such as getting up towards Toronto, there can be termites. So we have to look and take a look, especially for an inspector, to take a look, is there termite damage? Or the other way of looking at it, for new construction, because it's in a termite zone, now do we have to have protection for the wood itself? So sometimes you'll see some, what they call sort of color dyed wood framing, blue, green, I've seen some different colors. So again, taking a look at what does apply for your particular area. Certainly for a large part of the country, termites are not a big issue. So it's mostly in the southern, we'll call it more damp, milder winter areas. Okay, let's talk a little bit about this, the structural side of things. So when we talk about the Building Code Section 9.4 talks about the structural requirements. Well, we don't necessarily need an architect or an engineer to design all buildings. So we could have somebody who basically is very good at let's say, drawing house plans and being able to use the building code and follow it and basically come up with a good set of drawings to build a house or a building. But if we take a look at it, it says, when we take a look at the general structural design requirements in the building code, subject to application limitations defined elsewhere in this part, structural members and their components shall A, conform to the requirements provided elsewhere in this part. Boy, sounds like a whole bunch of legal language here, and it is technically. Be designed in accordance to good engineering practice, okay? Or be designed in accordance with part 4 using the loads deflections, which means basically engineering. So anyways, when we take a look at the structural requirements, pretty much most residential buildings, unless they get to be very large, you can basically build from the old traditional building standards. And again, as long as it follows the current building code. So again, there are some limitations, as it says, the applicational limitations. Is it 600 meters square? Is it 3 stories or less? Is it residential? And so on. So there's specific requirements spelled out elsewhere in the building code when it comes to the structural requirements. But I touch a little bit on the specified loads, because what happens in areas in the extreme north where we might have, when we think about a roof that basically accumulates a lot of snow on it. Is there a chance for roof collapse? And the answer could be yes. And likewise, we want to make sure that from a structural point of view, we want it to be a safe living environment for certainly the occupants of those particular homes or buildings. So another way to take a look at this is, again, there's the specified loads. And when we take a look at specified loads, it talks about this applying to light frame construction whose walls, floor, roof planes are generally comprised of frames of small repetitive structural members, such as 2x4s, or 2x8 floor joists, or perhaps 2x6 ceiling joists, or perhaps 2x6 for the roof joists, and so on. So the roof and wall planes are clad, sheathed, or braced at least on one side. So typically, when we're taking a look at sheathing, we probably would put some type of plywood sheathing. It might be even a rigid board type insulation. But with that, I usually recommend some diagonal bracing because we need to stop the wood frame from, we'll say, moving from side to side racking. Okay, so not more than 600 millimeters. Okay, so 24 inches on center. And the clear span of structural members does not exceed 12.2 meters, basically 40 feet. And the maximum deflection. So they talk about deflection. So again, over off to the side, a little illustration of some of these specified loads and some of these application. This type of building would fit into that category. Okay, so we can see here 40 feet, 12.2 meters. We can see your floor joist. The greatest you can ever get is 16 feet. And that's going with the largest size. And of course, just the framing in general. So again, we don't have to get buried into all the trying to figure out what does this formula do for us, unless you're an engineer. The other thing I like to talk about too, when we talk about structure and wood framing, is again, another part of the building code is called the climatic data or climatic design data. And it's found in the appendix of the building code. So again, I took some examples here. So for example, in this particular area, I took some from Saskatoon. Okay, and if I carry myself all the way over to the snow loads, because it talked about what about snow accumulation on a roof? Well, snow loads, basically the design limits, for example, for Saskatoon is 1.7, okay? And then we come over here, what does that mean in actually pounds per square foot for those that are in the imperial system? 35.5, just certainly shy of 36 pounds per square foot. Swift current, I give another example just to show you a little difference. Probably because it's what, a little further south. So just not quite 30 pounds, so 29.2. And then I jumped over to Manitoba and I said, well, let's use some extreme conditions such as Churchill, okay, up on the Hudson Bay. 3.0, which is basically 62.7 pounds per square foot. Look at these two. Double the requirements between 35 and certainly 62, or almost double, right? And another one, Lac du Bonnet, 54.3 pounds per square foot. So when we take a look at the building code, these are things we need to think about when we basically are building. So a 2x6 rafter in Saskatoon probably would work. But when we take a look at, for example, Churchill, maybe we need something much deeper and stronger to carry this roof load, because this is based on snow on a roof. And of course, there's other categories here. So these are for heating and cooling design temperatures. And over here, we can see wind pressure and accumulation of rain and so on. So I just wanted to kind of point that out, that when we use the building code, it helps us design better. And that's sometimes one of the elements that's missing if, well, a set of drawings is not always a good set of drawings, and sometimes there's some great sets of drawings out there. On the topic of structure, I want to talk a little bit about deflection. Well, maybe another term you might use, there's a dip in the floor. How much of a dip is actually acceptable by the building code? So when we talk about deflection, again, I like to use a little illustration because sometimes the words over here gets a little bit muddied because it tends to be legal mumbo jumbo of code requirements. Sometimes a little illustration helps indicate what is deflection. So we take a look at the original configuration, we see this horizontal line. But what happens when we have this dip in the floor or a beam? Okay, so configuration after deflection. How much is acceptable? Okay, and we could talk about the, we'll call it the structural engineering's compression or shear or as intention. Well, we won't go into that too deeply because I want to stick to the fact that deflection does occur and there's a reason for that. So, and again, the building code talks about how do we control deflection? What should we look for as a minimum building standard so people don't end up with these big dips or low spots on the floor. And what is acceptable? So again, the code talks about that. The maximum deflection of structural members shall conform to 9431. So again, I've copied here the maximum deflections for roof rafters and ceiling joists, or let's deal with floor beams and floor joists. Okay. Okay, it says in all cases, type of ceiling supported, okay, or ceilings and so on. But let's just go right across this line. It says 1/360th of the span. So that converts to in a 10-foot span, the allowable deflection is actually a 1/3 of an inch. Okay, and of course, if it was a 16-foot span, it's going to be, okay, probably closer to certainly more increased number. Okay, in a 10-foot span, allowable deflection, in this case, for example, for a structural member for a beam, okay, is 1/2 an inch. Well, 1/3 of an inch is, certainly not 1/2 an inch, but certainly there does allow it to have some deflection within the floor. So how do we stop basically, how do you stop the floors from deflecting? Well, sometimes it depends on what they call if there's camber up or crown up or crown down. And again, in the framing, hopefully the framers understand that you always want to have that crown facing up. Another area when we talk about certainly engineered wood products, such as those TGIs we looked at earlier, one of the big things that certainly a lot of fire departments are concerned about is fire and the pre-engineering of floor joists. Certainly a lot of homes and buildings today use this type of a flooring system. But what we have to remember is pre-engineered floor joists are made up of wood chips and glue, and they burn twice as fast as the traditional, we'll call it floor joists, wood floor joists more specifically. Traditional lumber joists burn in approximately 15 minutes versus 4 to 6 minutes for a wood chip joist. Well, I've heard in some instances where the fire department, if they knew it was an engineered wood product, they will not enter the building for their own safety. The floor could collapse on them. And certainly if they collapse, someone could be possibly seriously injured or perhaps even killed. So we can see there's 3 examples here. And the 3 examples in the building code basically say, okay, installation of a 1/2 inch gypsum board to protect the web of the joist. Okay, so basically this chipboard, I like to call it, in between. So this is solid lumber. This is solid lumber, okay, with a dado joint into it, with this sort of OSB board in between, okay, manufactured as a nice joist. But what we need to do is protect it with drywall on each side. How many homes have you seen do not have this? Or newer homes? The other way is, of course, we could box it in. Okay, so from we'll say the wood plate on top and the wood plate on the bottom, and then box it in that way. So system 2. So what they call over the entire flange. And the next one is simply almost like a lay-in ceiling. So again, drywall cut in between, sitting on top of these solid pieces of the joists. So again, things to think about, again, not just from a construction point of view, but also from a material point of view for the protection of wood, especially when it comes to pre-engineered floor joists. It's a great product, but certainly there's been addressed over time that there are concerns by fire departments that have to actually deal with this on basically a case-by-case basis. Okay, let's talk a little bit about what about the material on the outside. In the building code likes to call it cladding, which is basically your outside finish. So again, the building code requires a sealant to be applied to any location through which rain or snow would be able to penetrate and back up the assembly. It talks about the required sealant. We can see here, the siding is applied. It's being nicely caulked and sealed, nicely trimmed around the window. And when we think about this, the most vulnerable parts for water to penetrate through the structure is through the construction joints. And if the joints aren't reasonably tight and keep out the water and the elements, certainly they can creep inwards and cause damage to the, we'll call it the hidden structure behind. So again, under cladding, they talk about lumber siding. Okay, lumber siding shall be sound, free of knots, loose knots through checks or splits. Again, some description of the characteristics of different defects within wood. It talks about the thickness. We just don't want something thin on the sheathing or the cladding rather, but rather something of substance. And what about the joints? They talk about lumber siding shall prevent water from entering at the joints by the use of lapped or matched joints or by vertical wood battens. So again, there's the description of basically the material itself from point of view of thickness and width, and how do we deal with the joints. So any openings around the materials, such as at that window or a door, needs to be sealed. So again, we must think about it must be installed with proper joint treatment and flashing. Requires installation according to manufacturer's instructions. Again, does everybody read the manufacturer's instructions? Not always. In absence of recommendations, the code requires minimum lap coverage depending on the siding material. Requires secure attachment with approved corrosive resistant fasteners. So again, there's we go into the fasteners again. And they must penetrate 1 inch to 1.5 inches through the material. May require additional applicable requirements based on the design, wind speed, and certainly exposure. And again, a one size does not always fit all because, again, we have to look at the climatic differences between the north of a province and certainly the south of a province, end of a province, right? So let's get down to a basic review, kind of getting towards the wrap up here. So again, check the material for certification and grading levels. So again, you can see we have our grading stamps here, where it came from, and basically what grade it falls under. So in this case, select. Is the material suitable for the purpose it's intended for? That's what the building code basically asks. Verify material quality. Are you getting exactly what you paid for? Sometimes I've visited, and maybe some of you have visited. What about those ones that look more like a hockey stick than an actual straight piece of 2x4 or any other type of lumber? Are they sort of, kind of out of whack? Got a big bow in them? Are the joists and beams installed with the high point, the crown pointing upwards? So I mentioned that before. So we can see here, if the crown's pointed down, you're already fighting that whole early commentary about you're just adding to the deflection. But if we basically eye along the edge of either the top or bottom, we can see if it's either dipping downwards or upwards. It should be always installed by a good framer with what they call the crown up. Because again, once we put our weight on it, it's going to basically settle down to a more, we'll call it level playing field, and certainly not cause these big dips in a floor system. The other one I really like to caution people about too is, I know sometimes some of the communities are really challenged with what happens with the materials that we get. We have to store them because we can't build until next spring. So again, material protection is very, very important. We got a series of images from a few communities where basically this is gypsum board, and there was hundreds of sheets of gypsum board just basically destroyed because they weren't properly covered and protected. Not too bad over here, we have some roof shingles, but we also have other building products, wood building products. And if we take a look at it, muddy, water, wet, not ideal for basically a good build for a house. We're already fighting moisture and water issues here. And then we're going to have issues with, now, is this going to lead to more mold or quicker development of mold in a house? Okay, so getting down to characteristics, materials, and appliance systems and equipment. Okay, so we get down to what does the building code when it comes to enforcement talk about? All materials, appliances, systems, and equipment installed to meet the requirements of the code shall possess the necessary characteristics to perform their intended functions when installed in a building. So some of the characteristics I pointed out earlier are simply the things we need to look for when we think about even just wood framing. Wood building products, is subject to moisture, is subject to bending stresses, subject to deflection. Are we getting the right material? Is it okay for the span or the actual work that it's supposed to perform? So again, storage on building site. All building materials, appliances on the building site shall be stored in such a way to prevent deterioration or impairment of their essential properties. Again, when we take a look at things stored out in the elements, you gotta, it certainly raises the question of, is it going to be good enough for that particular build? Some closing thoughts. Lumber not grade stamped. Yes, building framing can be rejected if the lumber used is in its construction is not grade stamped. Now, that doesn't always apply because if there's no inspections, well, we don't know. We don't know sometimes until it's late, but during the construction stage, if it was inspected and we see that it is grade stamped, we're going to end up with a better quality build to begin with. So building inspectors generally will not approve a structure that has been built with ungraded lumber because they have no reliable way of knowing whether basically the structural materials will support the loads that they are supposed to be basically representing when we compare it to an ungraded lumber. The others have been tested and proven. The level of code enforcement certainly can vary. However, a lack of enforcement does not mean you should disregard building codes. It's important to check with your building inspector and permit office or permission to build office to determine exactly what exactly is required. And again, just to kind of wrap up here, a few resources I referred to. Booklet number 9 in our technical guide for Northern Housing series. That's with First Nation National Building Officers Association. And certainly when we take a look at the building code. So again, the FNNBOA Northern Technical Guide, the Building Code 2020. Some of the items were taken from what they call the Illustrated User's Guide, which is sort of a complement. It's not building code. It's just a way of illustrating and describing some of the parts of the building code for clarification. And certainly there was a large part of dedication and resources from the Canadian Wood Council. So that basically wraps up the end of my presentation for this particular session. Certainly, if you think there's other materials that maybe we could use some future webinars on, please let us know. Certainly, some roofing materials sometimes are another good topic. I did one on windows and doors, but certainly when we start to look at the building products, hopefully every community gets a better build, and I think that's what we're trying to strive for is better building, better built homes for First Nation communities, and not just for First Nation communities, for all of Canada in general, because hey, there's bad builders out there, and like I say, there's some really good builders out there, but you need to know what you're dealing with, and hopefully you don't run into too many problems where houses need to be replaced too quickly. Okay, Christine, I guess we're open to any questions.